Hi guys, how you doing? This is a review for quiz 8 in your modules. And this week we talk about something called confidence intervals. And a confidence interval is just a range of numbers, you guys. It's just a low number and a high number. So for the first question, we're going to talk about test scores. And they say that they're normally distributed, which just means a bell shape. That's all that means. And they give you some information. They tell you the population standard deviation is 2. You take a sample size of 25. It's about test scores. The mean of the test scores was a 72. And they want us to construct something called a 98% confidence interval. So the first thing you got to do is figure out which distribution we're going to use. Are we going to use our z-score distribution? And you have all these attachments, or are we going to use this new one that we call the T distribution? So you use the Z one if you know the population standard deviation. You use the T one if you don't know it. So let's see, what did part A ask us for sigma. Sigma is the population standard deviation. So that's 2, right guys? That's what that sigma is. N is just the sample size, so that's 25. And X bar is the sample mean, so that's the 72. Then they tell you to look at the flow chart and figure out if you're going to use this one or this one, okay? So if you look at the flow chart, the first thing, there's a diamond. It's one of the attachments, guys. There's a diamond. It says, do you know sigma? And sigma, yeah, we actually do for this, right? So you go to the left, you say yes, and then one of the questions is it normally distributed? Yes, it is. What does that mean? That means you use this z-score distribution, okay? So you're going to use this one. So put the T1 aside. So then you got to find, well, where's the formula for the z distribution? It's right here. To find the low end of the range and the high end of the range, you take the sample mean minus z alpha over 2 divided by sigma over square root of n and z, and the sample mean plus that same thing, okay? So what are all these numbers? Well, we know X bar, we know sigma, we know n. So the only thing we don't know is this thing right here. That's that z alpha over 2. That is dependent on this percentage that they give you for a confidence level. And I gave you a table that says z-scores for indicated confidence level. And I just wrote it on the back of this paper right here. So all you got to do is look at this list that I gave you. And this problem has a 98% confidence level. So I go down to 98% and I go across and I go, oh, z alpha 2 over 2. That's not z times alpha over 2. That's just a subscript. That's the name of it. It's 2.33. So I guess I should have wrote we're using the normal z. And then we're going to use this because we are using the normal z. So, and then I just looked it up on the chart, and z alpha over 2 for a 98% was 2.33. So now it's just plug-in time, you guys. So X bar is 72 minus z alpha over 2 is 2.33. Sigma is 2. Square root of n is square root of 25. And then you just do the same thing, but you put a plus. 2.332 over the square root of 25. So you just got to take your calculators out, you guys. And 2 divided by, that's 5, right? So 2 divided by 5, I think is 0.4. So you got to do 0.4 times 2.33, whatever that is, subtract it from 72. And I think I get this, you guys. I get 71.068. And on the high end, I get 72.932. So that's a confidence interval. It's just a range of numbers. So I guess the way you can interpret that is you can say, this isn't exactly the right way, but you can be 98% sure that the true population mean for these test scores is within this range of test scores. Okay, that's how you can interpret it. because we don't know the true population mean. We just know the sample population mean. Okay, so that should get you through the first question on the quiz. The second question on the quiz is about another test, okay? So let's see. So I can write it quick, guys. So number 2, it's another test scores. So remember, I just changed the numbers on the test, right? Normally distributed just means a bell shape. Don't know the population mean, don't know the population standard deviation. You don't know those. So you don't know population mean or standard deviation. They tell you that, right? They tell you sample of 18. Okay. And the mean for the sample, so the mean score on the sample of 18 was 72. Okay. They tell you the sample standard deviation, they have to give you that, was a 3. They want you to find a 99% confidence interval. That's what CI stands for, you guys. So first thing they're going to ask you for, what's X bar, what's S, what's N? So X bar is the sample mean. So the mean for the sample is at 72. S is the sample standard deviation. And N is just a sample size, you guys. So I think it's, okay. Then the next part, go to that flow chart and figure out, and I gave you the attachment for that, figure out if you're going to use this thing that we just used on the last problem, the normal, standard normal distribution, or we're going to use this thing called the T distribution. So the T distribution you use if you don't know the population standard deviation. Do we know the population standard deviation? No, we do not. It says don't know population mean or population standard deviation. So you go to the flowchart, so that pushes you to the right. Then it says, is the population normally distributed? Yes. If you look, it goes down, it says use this. Use the T distribution. So this time we're going to use the T distribution. So the formula for the CI, so T distribution. Okay, so the formula for, if you're using the T distribution for the confidence interval is pretty similar, you guys, but instead of Z alpha over 2, it's T alpha over 2, and instead of sigma, it's S. That's the only difference, you guys see that? T alpha over 2 times S over the square root of N. Okay, so I guess we have X bar, we have S, we have N. The only thing we got to do is figure out this and plug in. We don't know what T alpha over 2 is. That's where this table comes in, this T distribution table. And they tell us our problem said 99% confidence level. So if you look at my table that I gave you guys, 99% is the first column. But then they have something called degrees of freedom. And the degrees of freedom is pretty easy, you guys. It's just equal to n minus 1. So in our case, it's 18 minus 1 equals 17. Okay? So what you do is you go to the table. You go down to the degrees of freedom 17 row, and you go over to the 99% column. And that gives you your T alpha over 2. So you guys see that? Your T alpha over 2, that's supposed to be an alpha, is equal to 2.898. So make sure you see where I got that in the table, you guys. 17 over to the 99% column. So now, you guys, guess what? Plug in time. So X bar is 72 minus T alpha over 2 is 2.898 times S, which is 3, over the square root of N, which is square root of 18. And then you do the same thing, but you add. So you gotta whip your calculator out and do this stuff on your calculator, guys. And I ended up getting 72 minus 2.049, 72 plus 2.049. So when you do that on your calculator, I got 69.951 comma 74.049. So how do we interpret that? We're like 99% sure that the true population mean for this test is within these two test scores. But we only had a sample. We don't have the population mean. We have the sample mean. So we're trying to figure out what's the best range where we think the real mean is. Okay? So I know I did a lot there, but just stop it, pause it, stop it, watch it, rewatch it, ask me questions. I'm always available. Come to the Zoom meetings, you guys. Okay? Good luck. Bye.